All right, everybody, welcome to the video here for lesson number 4, finding the area length, the arc length, and area of a sector. So the opening exercise is definitely something that I want you to try first. So I want you to take a minute, talk about Danny's Pizzeria, and see if you can determine the area and circumference of his pizza pie. So if you want to pause the video here, take a minute, and see what you get for your answers here. All right, so hopefully you tried this. If you remember from class in a previous lesson, we learned about how to find the area and the circumference of a circle. A pizza is just a circle. So since the diameter is 16 inches, we know that the radius is 8 inches. So if we want to find the area of one of Danny's pizzas, we would say pi times 8 squared. So the area is going to be 64 pi. Type that in our calculator since it says nearest tenth. And if we do 64 pi, we get 201.1. To find the circumference of one of Danny's pizzas, we would say 2 pi times 8, 2 pi r. So the circumference would be 16 pi. And we got a circumference of 50.3. So what we want to be able to do now with Danny's pizzas is figure out, well, what would be the measurement of the crust of one slice of pizza, and what would be the area of one of the slices of Danny's pizza. So Danny's pizza is important because it tells us in the opening exercise here that it's cut into 4 slices, so it's a unique type of pizza. So if we have a pizza pie that's cut into 4 pieces, I'm only looking at this one slice of pizza. So notice it's 1/4 of the pizza. So if I take the circumference, which is 50.3, and I multiply the circumference for just the crust by 1/4, I know that the measurement of the crust of one of his slices of pizza is going to be about 12.6. The area of the total pizza pie was 201.1, but again, the slice is 1/4 of that. So one slice has an area of 50.3. So this opening exercise is basically describing what we're talking about here in lesson 4. In lesson 4, instead of us finding the area and the circumference of an entire circle, we're going to be finding the area and the circumference of just part of the circle. So let's dive a little bit deeper into Danny's pizza. So it says, from the opening exercise, we can begin to develop a formula for the area and circumference of a pizza pie. Each one of these slices is known as a sector. That's the fancy word for a piece of a circle. So the question I have for you is, what did you do in the opening exercise to determine the area and the circumference of a slice of pizza? So we divided by 4 because there were 4 equal slices. Now, to determine how many slices of pizza or how many slices of a circle we have, we need to know 2 different things about circles that we really aren't going to learn until the last unit of the year about circles. So I have to give you a little bit of vocabulary here. So the first vocabulary here is what's called a central angle. So a central angle is when a circle is cut into a sector by 2 radiuses. The angle where the 2 radiuses meet, that's called the central angle. So the definition, if we write it out in words, is an angle at the center of a circle created by 2 radii. The second definition is called arc length. An arc is basically just a distance around the circumference of the circle. So when we find the circumference of a circle, we're finding the full arc of that circle. When we're calculating a partial arc, we call it an arc length, and it's a portion of the total circumference. Now, in Danny's Pizza, each one of the central angles was 90 degrees. So if I look back here for a second, each one of these slices of pizza has an angle of 90 degrees. So my question to you is, how did I come up with 1/4 if the central angle is 90 degrees? Well, if one of the angles is 90 and a full circle is 360, that gives me 1/4. So basically what we're determining is the formula for how we can find the arc length. So the arc length of a circle is the central angle, theta, right? This theta is the central angle, divided by 360. This determines the portion of the circle times the full circumference. It's exactly what we did with Danny's Pizza. It just looks fancy because of all the symbols. Notice the letter that we use to represent the arc length is S for sector length, right? You don't really have to use S, but we just will because that's what's in most math textbooks. So let's try this out. So here's an example. So it says determine a length of AB. Notice how there's like a little arc over AB. This is asking us for the arc length of AB in symbols. So essentially what I want to know is how far is it from A to B on this curved edge, the crust of the slice of pizza, if you will. So the formula for arc length, like it is on the previous page, is central angle over 360 times 2 pi r. So this arc length is going to be 60 divided by 360 times 2 pi r. Now, I'm going to find this answer in two ways because it doesn't tell us what to do here. I did that on purpose so that we could discuss how we can actually show this answer. We can show this answer in terms of pi. So in terms of pi means plug everything that you see here into your calculator except for pi, including the radius, which I should have put, of 12. So in your calculator, you're going to put the fraction 60 divided by 360 times 2 times 12. Notice, again, I'm not plugging in pi here. And we're going to get 4 pi. That would be our answer if the question said in terms of pi. Now, if this question said like nearest 10th or nearest 100th, we'd actually evaluate. So we'll say nearest 10th, just to put it in the calculator. And then we just type in 4 pi since I already put it in terms of pi. And we get an S or an arc length of 12.6. Again, it's all going to depend on how they ask the question, so you have to be prepared for both. Now, one of the things that we have to remember here is when we're doing in terms of pi, just type everything you see except for pi. Let's try another one. Example 2 talks about Christine's onion garden. It's in the shape of a sector and it needs to be fenced in. So as soon as we see fenced in, you're probably thinking perimeter. So notice Christine's garden has a length of 50 feet in one direction and 50 feet in the other. Those are the radii of the full circle. Pretend there's a full circle here. We want to know this value, the arc value. So since the central angle is 132, that's my theta. So I can say the S value in this problem is going to be 132 divided by 360 times 2 pi times 50. Now again, this doesn't say in terms of pi, but if you think about it realistically, if you were building Christine's onion garden fence, you don't want to know the length of fence in terms of pi, you'd want to know it as a decimal. so you can figure out how much fencing you actually need to buy. So the length of S, we'll round to the nearest tenth here. If I type this whole thing in my calculator, divide by 360 times 2 times pi, notice this time I'm putting in pi because I want the decimal, is 115.2. Now that's just the length of S. So the total perimeter of Christine's garden is 115.2 plus 50 plus 50. So her total perimeter is going to be 215.2 feet. Again, it would be more specific if it was a test question telling you exactly what to round to. But again, since we're talking about fencing, I don't want in terms of pi here. Now, to add an algebra twist here, it says the local hardware store sells fencing in 35-foot long bundles. Determine how many bundles she needs to fence in her onion garden. So if I take her total perimeter, 215.2, and divide it by 35, that should tell me how many bundles I need. So if I do 215.2 divided by 35, that gives me 6.14 dot dot dot, which means I need 7 bundles. 6 just won't be enough. All right, let's keep moving. We could do the same thing with the area of a sector. So when we're finding the area of a sector, we're going to do that same process. We're going to figure out the portion of the sector that we're talking about, and then just multiply it by the area of the total circle. So again, this theta represents the central angle, and this represents the area of the whole circle. What's in that parentheses is determining the portion of the circle that we care about. So let's take a look at number 3. So number 3 says Anna has a circular patio with a diameter of 26 feet. As soon as I see the word diameter, I automatically know radius is half of that, so 13. She wants to separate her patio into 6 equal sectors and paint each of them a different color. What is the area of each sector of the patio? So if I have a circle, 360 degrees, and each sector is the same size, and there's 6 of them, I now know that the central angle is 60 degrees. So if I have my circle, one of these sectors is going to have a radius of 13 and an angle of 60. Because all 6 angles have to add up to 360, and since all 6 angles are the same, I can figure out the central angle. So now the area of this sector, we'll just use A for area, is that 60-degree angle divided by 360 times pi times the 13 squared. Again, it doesn't say what to round to here, so we'll do in terms of pi. And then we'll do nearest tenth. Just to practice both. So in terms of pi, I'm going to plug this all in without pi. So 360 times 13 squared. It's going to be a decimal. Hit math, enter, enter. It's going to be a nasty fraction. That's fine. 169 over 9 pi. Remember, to get a decimal to a fraction in your calculator, just hit math, enter, enter. Now, if I type all that in with pi, so type it all in again, but now this time actually include pi in your calculator, or just hit times pi in your calculator since it's already in there, you're going to see an area of 88.5. All right. The only trick to this next question is the picture. So here we have a circle. It tells us that the triangle FGH is inscribed in the circle, meaning all 3 vertices are on the circle. It says circle O. This tells us O is the center, meaning I know all 3 of those segments are the same size because they're all the radius of the circle. Now, it also tells us that FH and OH are the same. FH and OH are the same, making triangle FOH equilateral. Equilateral means the angles are all 60 degrees. So now I know the central angle is 60. Now it wants us to determine the area of the sector created by central angle FOH. I'm only talking about, and let me use a different color here so it doesn't get confusing. I'm only talking about this sector, which is good because that's the only sector I know the angle of. So now if I want to find the area, I would say the central angle divided by 360 times pi times the radius squared. Now notice this one says in terms of pi. So if I type in 60 divided by 360 times 6 squared, I get 6. So this answer is just 6 pi. You notice a lot of the examples here all have a central angle of 60, except for Christine's onion garden. That's not always the case. It's just easy triangles to make. So let's take a look at number 5. Number 5 would be one that if we were in class, I'd say try on your own. So I want you to try it on your own, pause the video for a second, try it, and then see if you get the same answer as me. If you don't, no big deal. You could just adjust to what I did. So go ahead, pause the video and try this one on your own. All right, hopefully you've tried this on your own. So here's my angle of 60 degrees. This is a central angle. But I don't care about that sector. I care about the shaded sector. So I could do one of two things here. I can either find the total area of the circle and subtract the area of this unshaded sector. Or if I was really smart, I saw that this angle is going to be 360 minus 60. So this central angle is a really big angle of 300 degrees. So I can say the area of this sector is 300 divided by 360 times pi times 8 squared. Notice it says nearest hundredth, so we don't need in terms of pi here. So we're going to type this whole thing in the calculator as we see it. So 300 divided by 360 times pi times 8 squared. So this area in our calculator becomes 167.55. If you're not getting that answer when you're typing in the calculator, play with the calculator a little bit. You're probably just typing something in wrong. Use parentheses. And that's it. Hopefully this video helped, and you could go ahead now and start your homework. The homework video will be a separate video that I'll post on Google Classroom. Hopefully this helped, and I'll see you soon.